In this video, we'll look at how to factor a polynomial and then we'll sketch it. Very rough sketch. So let's start with first just identifying some of its properties that are going to help us when we go to sketch it. First, the degree. Clearly, the highest exponent is a 3, so the degree, oh, this pencil isn't great. So this degree is 3. I'm going to switch pencils. Always have a backup pencil ready to go. Nice. Degree is 3. What's the leading coefficient? It's a 1. There's nothing here, so it's a 1. But I want to know the leading coefficient sign, which in this case is positive. How about the y-intercept? I can calculate the y-intercept by setting x equal to 0. When I do that, I get y equals 0 cubed minus 7 times 0. You might have been able to see this, that it's just going to be 0, take away 0, take away 6. So the y-intercept is negative 6. You might want to write it as a point. The y-intercept is 0, negative 6. Oh, could have written it right up here. Save some pencil lead. But the x-intercepts are going to take time. We need to figure out what the x-intercepts are. Well, we do that by using remainder theorem and factor theorem. We need to find an x that can factor this. I usually say try small integers, because that's usually what you're going to get, are small integers like 1, 2, 3 or negative 1, 2, 3. Let's try x equals 1. We try x equals 1, we're going to get, so let's see, positive 1 cubed minus 7 times 1 minus 6. 1 cubed is just 1. Nice. Take away 7, take away 6. Oh, not so nice. 7 times 1 is negative 7. That gave us, no, that wasn't good. Negative 13. Or you could just say at this point, look, Bergman, Mr. Bergman, I know it's not 0, which I want. Okay, try something else. How about negative 1? Alright, negative 1. Sub in negative 1. You get negative 1 cubed minus 7 times negative 1 minus 6, which gives you negative 1 cubed is minus times minus times minus, negative 1. But here, I did this on purpose because I saw here, if only this were positive, which it would be if I got negative times negative, positive 7, minus 6. Again, you can use your calculator, but minus 1 plus 7 minus 6 is 0. Nice! I've got a factor that works. I'm going to use it to do synthetic division. I recommend watching the video on synthetic division if you don't know how to do it. I'm going to use my 0 for synthetic division, which in this case is negative 1. I'm going to write down my coefficients, but be careful. Coefficient of 1 here, there's no x squared, so I need a 0 there. And then there's a coefficient here of negative 7, and then a negative 6. Again, please watch the video on synthetic division if you don't know what I'm doing here. Bring down the 1, multiply, add, multiply, add. And again, use your calculator if you need to do negative 7 plus 1 on a calculator. Gives you negative 6. Multiply. Gives you a positive. Add. And then we're done. This is my remainder. So these are my constants. These are my x's. This is my x squared. So we factored this equation now. Pulled out this x plus 1. Remember, the 0 was negative 1. So the factor was x plus 1. And this was remainder constant x, so it's x squared minus x minus 6. And now we need to factor this remaining quadratic. So I need to put an arrow. I'll go up here and say I'm going to factor x squared minus x minus 6. I'm trying to multiply to negative 6 and add to negative 1. You can watch videos on factoring if you're not sure how to do this. What multiplies to negative 6? Adds to negative 1. The numbers are negative 3 and 2. So we get this equals x minus 3 and x plus 2. So we have y equals our original factor, x plus 1, and these two new factors from factoring this into this, x minus 3, x plus 2. To graph it, we've already got the y-intercept, but we still need the x-intercepts. We've almost there. We've got the equation factored form. Now just solve for the zeros by setting the equation equal to 0. I know some of you will be like, oh, I can see them. Yeah, you should still show the work. That is, you set the equation equal to 0, and either this bracket equals 0, and or the second bracket equals 0, and or the third bracket equals 0. You won't believe how many people make mistakes when they don't show this step. Now we have our three zeros, negative 1, 3, and negative 2. So now we're ready to draw a sketch. A sketch is a rough graph. For me, you should still put the arrows and the x and y, and just label the points of interest, which are the zeros and the y-intercept. So here we have down here at -6, that's going to be our y-intercept. Gives me some idea of the scale I want to use. So maybe around here at -1, I'm going to have one of my zeros. And at -2, that's from this one, I'm going to have another one of my zeros. And at +3, I'm going to have my third zero. You should watch a video on cubics if you don't know what this shape will look like, but all cubics that are positive, there's a cubic that's positive, will start here in quadrant 3. It'll go up through that zero somehow, then come back down through the next zero, and it's got to hit that y-intercept, and then come back up through the last zero. So what we did here was we identified some of its properties. Degree, leading coefficient sign was positive, and the y-intercept. And then we factored using factor theorem and synthetic division, and then later just factoring a regular quadratic in order to get it in factored form and find its zeros. When we had that, we had enough properties to draw a sketch. So that's how you factor a polynomial and then sketch it.